First one's tomorrow. Okay, with Justin. Justin's here, by the way. Raise your hand, Justin. There's Justin right there. So Justin's the one that he's going to do the SI sessions. We have the room now for Thursday, so it's no longer to be announced. Now it's in the Creative Arts Center. Creative Arts Center is a little bit confusing. Is it still confusing in there?
Yes.
You'll see like students cowering in the corner who've been lost for days or liquor all night, dehydrated, near death. So do your best to try to find the rooms. People should be fairly friendly there. They'll let you know where the rooms are, but it is a little confusing in that building. But please try to go to those if you can. Again, review sessions. There was actually a fairly good turnout from what I understand last week. That made me happy. Tutoring, again, every day to Friday. There's our office hours. There's email. I'm actually getting a pretty decent amount of email that makes me happy too. So far so good. All right. So what we're going to do is we're going to continue talking about what we were discussing. And what we were discussing is how the cells make ATP. So how do we make, and I shouldn't say we, I should really just say how do cells make ATP. This is the process. This is just quick review. We've already done this, just to kind of get us going and into the flow of things. Cellular respiration. As soon as you see cellular respiration, that's what you think. That is a cell making ATP. It can do it in two ways. Either it uses oxygen or it doesn't. If it's not using oxygen, we call it anaerobic. If it is using oxygen, the cell that is, we call it aerobic. And then we drew that picture right there. That's what we ended with last Wednesday. Was that picture right there? Is that aerobic or anaerobic? Anaerobic. You don't see oxygen written in there, do you? You do not. Where does this happen, by the way? Can you remind me? Happens in the cytoplasm, correct? So anaerobic cellular respiration happens in the cytoplasm. And we're going to make ATP by doing what to glucose? What do we do to glucose? We split it. So what's that called? Metabolically, we call that catabolism, right? This is a catabolic reaction that's occurring. This molecule gets broken up into these smaller molecules. So by definition, that is catabolism. In so doing, and there's 10 reactions that are occurring. We don't care what those 10 reactions are. In the end, we're going to get a couple of ATPs. And we're going to get a water molecule as well. And I think I mentioned that heat is produced. We're not quite done with the anaerobic cellular respiration. Glycolysis, which is taking glucose and catabolizing it into pyruvic acid, that's what glycolysis is, but we're not done with anaerobic cellular respiration. One more step that you need to be aware of. What's that step? This gets converted into that. Now we're done with anaerobic cellular respiration. So the acid that's produced during anaerobic cellular respiration, in the end, is lactic acid. Certainly pyruvic acid as well, but there's our waste product right there. Okay? Are we good? Is this part of anaerobic cellular respiration? No, that's why I cut it off right there. But it's something that I'd like you to know. The Cori cycle occurs and causes the conversion of lactic acid into glucose. And I think I told you why that happens. This is happening to get rid of the lactic acid from your muscles. That's mainly where that lactic acid comes from in the Cori cycle. All right? That is how we concluded on Wednesday. Now what are we going to do? Now we're going to compare this to aerobic. All right? And when we talk about aerobic cellular respiration, we have to talk about the mitochondria, because that's where it happens. So aerobic cellular respiration occurs in the mitochondria. And when Lecture Seaver talked about the mitochondria, she called it what? The power factory of the cell. Why? Because it makes a whole mess of ATP. So what we're going to do here is we're just going to draw a rectangle. The rectangle is going to represent the mitochondria. So that is a mitochondria right there. And there's going to be stuff that happens inside of it. And again, it's going to be aerobic cellular respiration that's occurring, so we'll just write it up here. Now what I want to do is, again, I said I wanted to compare aerobic and anaerobic cellular respiration. In order to make a direct comparison between the two, I'm going to start with the same thing. So I'm going to start with glucose as well. Although with aerobic cellular respiration, glucose isn't the only thing that you can use. You can use fat, you can use protein. Well, really amino acids and fatty acids, we'll talk about it later. What's the only thing that we can use with anaerobic? The only thing? It's glucose. That's the only thing you can use with anaerobic cellular respiration. The only thing. Aerobic, different story. But again, I want to make a direct comparison between the two. So I am going to start with glucose. And in order to start with glucose, we need to do the same exact thing that we did to glucose. We need to catabolize it. And when we catabolize glucose, we're going to get our pyruvic acids again. So out here, I'm just going to quickly do that. So we're going to get our 2 pyruvic acids. Now, anaerobically, what happens to pyruvic acid is that it's converted into lactic acid. Anaerobically. Aerobically, the story is different. What's going to happen to the pyruvic acid aerobically is it's going to travel into that mitochondria. Again, that's what this is. So it's going to be transported. Both of these are going in here. So now the pyruvic acid is not going to get converted into lactic acid. It's going to get converted into something else. And what that something else is acetyl-CoA. And that's going to be our first step in aerobic cellular respiration. That is the conversion of pyruvic acid into acetyl-CoA. Each one of them is. So what we're going to get are 2 acetyl-CoA molecules. Why? Because there are 2 pyruvic acids. And there's something that we yield from this conversion that you need to know about. Now, there's other things that are yielded as well. We're not going to worry about it. The only thing that you guys have to know is this. We're going to get a CO2 molecule. What's CO2? If we have to spell it out, that's carbon dioxide. And carbon dioxide is an acid. We'll learn about it in more detail next semester. So the acid that's produced during aerobic cellular respiration is not lactic acid, it's carbon dioxide. All right? You with me, guys?
You said carbon dioxide is a liquid?
Acid.
Acid. I thought it was a gas.
It's a gas that gets turned into that as an acid as well.
Okay, so it's at a lower temperature.
At a lower temperature. No, CO2 is around regardless of what the temperature. We can lower it to where you. That'll be something we'll talk about next semester. A lot of detail. Okay? Now, acetyl-CoA is now going to go into a series of reactions. And those reactions are called 3 different things. Krebs cycle, TCA cycle, citric acid cycle. It's all the same thing. I'm going to call it Krebs because it's the shortest word. So, I'm going to do this. I'm going to draw a circle in here. That circle represents 9 different reactions. All right, so that's Krebs cycle. Again, also known as the TCA cycle, also known as the citric acid cycle. Acetyl-CoA is going to enter into one of the reactions within the cycle. And when it does, and as we go through these 9 different reactions on each of those cycles there, stuff is going to be produced that we need to be aware of. Once again, we're going to get CO2, and this time not just 1, but 2 per. So each acetyl-CoA is going to give us 2 CO2s. So we're going to put 2 over there and 2 over there. So far we have 6. All right? 2 from the previous reactions. 1, 2, plus 2 is 4, plus 2 is 6. I need you to know that. All right? What else do we produce during the Krebs cycle? ATP. So we're going to get an ATP molecule here and an ATP molecule here. So far we have 2 ATP molecules with aerobic cellular respiration. That's all I need you to know. All right, NADH and FADH2 are produced. We're not going to worry about those molecules, although it's in your notes. So if you notice on that page of notes, I'm not talking about some detail within those notes. You don't have to know it. All you have to know on that entire page is what I'm drawing up here right now. So you don't have to worry about NADH, and you don't have to worry about FADH2, wherever it is. You're not going to have to worry about the proton gradient. There's a bunch of stuff you're not going to have to worry about. All right, I just don't think it's that important. You take biochemistry, you're going to learn about that stuff in nauseating detail. All right? So now what? Now we go